Hello CIS27. In this video, I'm going to talk about Unit 5. And in Unit 5, we are going to cover Chapter 5. So this video is broken into two parts, and this is part 1. So in this chapter, we're going to talk about hardening OS and application. And the important thing to remember is that operating system and applications usually have vulnerability that's built in or flaws that we would see. So to start, we would make sure that our configuration is changed from the default, not using default username and password, change the settings that's needed for the operating system, and importantly, we wanted to be able to run updates or install updates. Before we run updates, we want to test the updates and be able to deploy that on our infrastructure. Now, installing updates is going to help you close some of the security gaps that exist in the application itself, like Microsoft, that provide operating system and application for businesses. You would see that they would list the type of vulnerabilities on their website, such as this one. So I simply search for Microsoft Common Vulnerabilities, the CVEs, and throughout time, Microsoft lists the known vulnerability with the ID. So for example, if we're looking at remote development extensions or even Internet Explorer, Azure for the cloud, you can explore further by clicking on the vulnerability and how to fix some of the vulnerability, whether the updates include some of the vulnerabilities. So if there has been some security updates for the type of tool, then it would list it under the security updates. And this is provided by Microsoft. Now, other vendor or community also offer a list of common vulnerability in their operating system or application. So it would be important for us to check this out and make sure that our updates address the vulnerability that exists in that application or the software, such as the operating system. And we wanted to also look at least functionality. So when we deploy the application, we wanted to look at how we would only target the application and the services and the protocols that are needed for business operation. And we don't want to allow the services and protocol and applications that are not necessary for daily operation, because that would increase the risk for the business and because those applications would have existing vulnerability. So we can look at how we can uninstall some of the unneeded software or the services, packages that would tie to some services, and also the protocols and the ports that would relate to unnecessary usage in our network. Now, the accounts, some applications and operating system would come with guest account, and for most part, guest account would be disabled. But in the case where if you have users that are no longer in the network or guest account that actually is activated, we want to put limitation on these accounts and we want to disable them when we don't use them. And all software would have backdoors. So backdoors are put there by developer and designer to go in and be able to make modification for in the future without having to acquire additional privilege. So usually backdoor is placed at the highest access level. So we wanted to work with developers and organizations that provide the software tool to reduce and remove the backdoors so that way it doesn't impose the risk in our environment. So for the first question in your assignment, we wanted to identify the security approaches to protect our system, and our system would use operating system or application. So first we need to list change configurations from the default, and we need to install updates to reduce the risk on the software and the application and the operating system. Second, we wanted to deploy only the applications and the services and the protocols that are needed to make sure that we reduce the vulnerability in our systems. Third, we want to uninstall the unnecessary software. Next, we want to disable unused accounts and limit guest account usage. And then lastly, we want to remove the backdoors and work with the third-party vendor to make sure that that is removed when it's deployed in our infrastructure. In the next part, it goes into the operating system. So the common operating system that you will see in the field would be Windows, Mac OS, Linux. Windows take up 80% of the businesses. Most businesses use Windows Server or Windows Client systems, which encompasses 7, 8, and 10. Most of the time, everybody is updated to 10 now. Microsoft announced that they no longer release other versions outside of 10. They will continue to maintain Windows 10 and push updates for Windows 10. So it's important that we plan, test, and coordinate updates for the client desktop or the client system, along with managing the server roles and also updating the server system. So the server operating system for Microsoft includes 2012, which is older. Most company would use 2016 or later, such as 2019. But you might see some older system that have legacy archive file that uses the older operating system, and we want to make sure that we look at the compatibility with the software before we upgrade, in any case, to a newer operating system, along with maintaining the updates for the existing one. And so that way we would minimize or mitigate some of the risk that's involved with the software tool that we're using. Mac OS is now introduced more in a mixed environment, and it's often used as a client system. Rarely that you see Mac OS used as server, because the server functionality for Apple devices can be difficult to maintain, especially in the area of compatibility with other servers. So you often see them being used as desktop or laptop systems, and then even the tablet and mobile devices. So on the Mac OS side, you would see nickname being used for different version, and most people would refer to it as Mac OS X. The X represents the version number that will be released. So, and Apple has been really consistent in providing updates and upgrade capability for their users. And so we want to make sure that we look at the available upgrades and updates so that way we can transition with our existing application that would be needed for the business. Because availability is one of the key area for security, and we don't want to launch anything without testing. Linux is commonly known as open source operating system, but not all Linux operating systems are open source, such as what you would see with Red Hat that will require licenses for their servers, and then SUSE would also be required for licensing. But the majority of the Linux operating system would be open source, and you often find Linux server being used for web and other roles. So here lists a common type of Linux, and Debian is basically a type that encompasses different versions or releases of Linux. So now in the open source environment, even though it's free when you use it for educational and non-commercialized purposes, we also need to take a look at the support capability, how the community is able to support, especially with drivers, in the case where if you have new devices, hardware devices that needs to be attached to the system, Also support it with services and compatibility with the application that we use. So it's always important to think about how we would transition from our existing system state to a newer operating system or something that will be different in our environment. So it's best that we would test it, and the way we would test it is to use virtual machines or sandbox environment, um, to make sure that we see, potential issues and plan to address those potential issues. Kiosk network appliance and non-persistent operating system. Most of the manageable appliances in the network, like Cisco router switches, Juniper, Arista, those brands would have operating system on their appliances, security or network appliances, and it would require some management capability. And kiosks would be that what you would see with sales kiosks, kiosks that would allow the user to make purchases, process transaction, look up information, etc. And all of these would have some form of operating system or application that would be used. And so sometimes in the management area, we wanted to make sure that we provide power, and because data is retained when the power is on. And a lot of these kiosks and network appliances would be attaching to the greater network. Either they are part of the hierarchical network or they are a sub component in our network environment. Now, with the Trusted OS really emphasize authentication and authorization, making sure that we establish that trust for the system to communicate. And that ties back to how we authenticate the system and what we permit those systems to do. Now, in deploying a larger scale network, we would see master image being used. And this is simply a snapshot of a single system that would consist of applications, configurations, and settings that we can use across many other type of systems. So if you have 100 PC, what you can do is you can create a master image and install the appropriate tools, applications, and set up the configuration for that image, and then use that image to copy that image or deploy that image across multiple 100 other systems. So that way it streamlines the effort, the support, and it gives you consistency throughout. And consistency is important in security, that if we started with the settings to close out some of the security issues, we want to make sure that's consistent across hundreds of systems, so that way we don't have a mismatch situation where we have potential unauthorized users accessing that system, or we would have some misconfigured policy on the systems that doesn't have the appropriate settings. So master image is important. It helps us in the maintenance, support, secure, and a lot of the other areas as part of our infrastructure. So in the second question, it asks you, what is the master image? And a snapshot of it is a snapshot of a single system that is used to deploy on multiple systems. And we would be able to have consistency by doing that. Now, in the next question, we would address some of the areas that would relate to the tools and the automation. So in network, we have all types of different appliances and systems. We want to make sure that we look at the settings that will give us the consistency and security. And we wanted to refer back to how we would apply the rules for the business operation into the systems, such as, you would allow employees to log into the system, during operational hours, so we can set up the privilege and the user rights along with permissions to be able to control systems and files and objects inside our network. And that overall would help us reduce the cost. Virtualization tool, as I mentioned before, would be used to test and convert image into virtual systems. And virtual systems is essential because we can minimize the cost by using virtual machines, as what you've seen in practice lab, and use those virtual machines to be able to maintain data, to manage, to monitor, and lots more. Um, so now, because in a large-scale network environment, we have a lot of different type of processes, from adding user accounts when we have new employees, to reconfigure our switches, routers, or to copy files, and be able to replicate and duplicate some of the data that we need across our network in a larger scale. So what we can think about is how we can automate some of this. And in automation, we can use scripting, and such as Python scripts, and be able to implement templates so that way we have consistency across. There's no mismatch, or it would also help us in efficiency, and it's going to be effective because it would reduce the amount of work that you have to do. So you can deploy automation script on a control system and aim toward all the targeted system, which are the connected systems that needs that script on the network, instead of doing it repeatedly over so many systems. We can have one control system to be able to launch the script and automate the tasks. Things like we would use that would be Ansible framework. We can use Python library to automate some of the tasks. And in CIS30B, I address this, understanding more on how to establish automation for network environment. Next, it talks about security baseline and integrity measurement. And to improve our overall security posture for our systems, we usually start with the baseline configuration, the tools that needs to deploy for consistency. And with that, what we can look at is the trend over time, and we can make modification and apply change management. So the baseline would give us an idea of how we should monitor the systems and how we can scale the system for expansion in future time. The area for remediation, we would use network access control methods, which allows us to detect some changes in the baseline settings and automatically isolate or quarantine the system. This is important because when you have malware that make system adjustment, system settings adjustment, then we will be able to detect that for that particular affected system. Or in the case where if you have unauthorized users that would come in and make modification without your knowledge, we would need to have a detection in place to make sure that it doesn't change, and making sure that we isolate that system so it doesn't affect the rest of our network. So in the next question, it asks about securing network. So in question 3, how do you secure a network with multiple types of systems or operating system? We want to use patch management, which means that we need to test, install updates, and we want to use templates, so we would have consistency across our settings. And we wanted to establish the baseline for configuration and look at the trend in our system usage and scale it over time. For question 4, what is the strategy in securing automated system? We can use scripting. We can use templates, we can use encryption, and we can use permission to control the information that we incorporated in our scripts and in our deployment of the automation process. So these are some of the areas that would focus in how we would secure automated system, including cloud environment. For question 5, what is the purpose of security baseline in the organization? It is used to establish measurement in systems, detecting changes, and it allows us to control change management through monitoring. We want to make sure that we detect and monitor potential changes. So we would understand that at the minimal level, how should our system be configured? How should it operate? What kind of consistency do we have across these systems as far as settings and connectivity, applications, etc. So security baseline look at the areas that we secure across our network and how we would be able to monitor that. And the tools that you can use on Microsoft system would be Microsoft Baseline Security Analyzer. It looks at weak passwords, existing vulnerability, outdated applications, and some of the security tool that you see with like the security suite that you would use, Symantec, McAfee, etc. Those actually give you some configuration baseline, but in a larger scale network, you would use the NAC type of application or tools to be able to manage security baseline, where it would report and raise a flag in case if there is something that's changing or that's happening, so that way you can isolate the necessary system and avoid negative impact in your infrastructure. Now, next we're going to get into patch management and change management. So on page 1 and going into page 2, it talks about patch management. Patch management ensures that our system and application stay up to date. And by staying up to date, we close out some of the security issues or reduce the risk in our system. And we can use different methodologies, but we can make sure that we need to test, deploy, and verify before we install the updates. We do on a larger scale, we don't do automatically install updates because it might cause incompatibility with our applications once the updates is pushed, or it might cause disruption because it terminates some of the service. So we want to make sure that we identify what version that we need, what type of updates that we need or fix that we need. Download, we need to test, deploy, and verify. So in patch management, we focus on how we can update our applications and our operating system and making sure that it's up to date and we can close out some of the security gaps. In change management policy, we define the process in system modifications and upgrades. So if I want to upgrade my server, I would need to plan and think about how the server, what kind of content the server is serving, what kind of impact that server would have on the rest of my network. And we need to make sure that we address the goals, ensure changes in IT system that do not result in outages, making sure that we address availability there. And second, we want to provide accounting structure or method to document all changes. So in the case where we have changes that negatively impact our systems, we can go back and look at how we track the changes over time and possibly think about how we would address or troubleshoot that system in case that if it causes disruption or it has negative impact. So in the next question number 6 asks you the difference between patch management and change management. Patch management ensures that the system and applications stay up to date with current patches. And again, we wanted to identify, download, test, then deploy. Change management defines the process in case that any of the system is being modified or upgraded. So patch management really encompasses the updates, but change management includes patch management. So in order to have effective patch management, change management policy needs to be in place. And so that way, when you update, it causes the system to change, and that change is included in change management policy once that update has been tested and planned accordingly. So now going back to the notes, we need to take a look at how our software and compliance measure is needed. So in compliance, we need to take a look at company operations. So for example, a healthcare facility would need to be complied with HIPAA, where they protect patient records. And so that really relates to how we use the systems, how we protect our data. So there are other requirements for other compliance like Sarbanes-Oxley compliance for the company that are publicly traded in the exchange market. So with that, what we have to think about is how we would disallow the user from installing any kind of software because it will introduce potential threats like malware, or it would impact our system. So we can control the user rights and privileges through disallowing them to install any kind of software. And software licenses is important, especially in the area of audit for compliance. We want to make sure that the software tools that's installed is going to be allowed, and making sure that the licenses are met and they're not using any kind of pirated software. And in order to fix this, what we can do is we can screen the software, the application that's being used outside of setting up user rights. We can create a whitelist of the application that are acceptable in our network, and we can also block the applications that are not allowed on our systems, which is we can create a blacklist so that way unauthorized application will not be allowed. And when we wanted to really test security or test updates or test applications, we can create a sandbox environment in which we would simulate and isolate an area of our system or our network to test. We can use virtual machines like what you've seen in practice lab. We can set up different type of virtual machine, including the Linux systems. And in Linux system, you can use chroot command to change the root directory for an application so you can isolate it and not have it impact the rest of your system configuration and files. And after we test, we can think about how we would develop control and change management to track application development. So at this stage, most of the time if we have in-house development team, we would work concurrently with them to make sure that we manage the change and how the application would impose change on our system. If we have a third party, like a vendor like Microsoft or a company that provide the applications, we want to look at how we would have version control and work with our vendor to make sure that we track possible changes that that application is imposing. Then next we would test, and we can test hardware and software using test modules. So if we add in new hardware in our network, we also need to test and see how that hardware would be compatible or it would affect other systems in our network environment. Same thing with software. If we introduce another application, potentially it can have positive or negative risks. So we want to make sure that we simulate this and test it before we actually deploy or go live with those type of systems and software tool. And production really means that we would use it for operation, where the system would need to be supported, maintained over time. So for production system, you would see like servers, authentication systems, certificate type of roles being used, etc. And before we go into production, like I said, we want to make sure that we track, we test, we make sure that the change is managed through policy, and making sure that production system is going to be well maintained. So in the next question of our assignment, it asks, what is sandboxing? And it is an isolated area of the system that's used for testing. It could be a group of systems that being set up for sandboxing, or it could be one individual system, depending on the need of what we're testing. And for question 8, how do you implement secure staging in system development? And in development, that's when we would create codes, or we would have teams that write code for applications or for the tools that we use. So we wanted to implement version control, and you can use Git, like a common one would be GitHub, but we can manage the version. We can also have change management control to track application development in different stages. And in many cases, depending on the model that development team uses, sometimes they would test concurrently with the development stages, and sometimes they test at the end when the development is complete. But testing doesn't only include software, we also can include hardware. So tests would include hardware and software for the test module. For production, that will include system and support. So those are the 3 things that you need to add for number 8. Next, we're going to talk about peripherals and the impact of peripherals to our systems and network. So the common peripherals, you can see Bluetooth, wireless devices, digital camera, external storage, printers, multifunctional devices like printer, scanner, printer, and fax machine all in one. And those would be the embedded system that has storage. All of these systems would have some kind of processors, some kind of storage. So the downside of this is, if we allow the use of peripherals, which we have to, it can create leak of data, or in the case if the device is lost or stolen, that can fall into the wrong hand, and it might leak images, data essential to the company that will be proprietary to the company. So we have to really think about protection means, starting with firmware. Firmware is a set of codes that was created to make sure that that system is recognized and it handles the instructions for the system. So for example, external storage uses firmware to allow itself to be recognized by the system that it's attached to, and then it would understand the instruction for file copies, creating files, etc., folders on that storage device. Now, we wanted to make sure that the firmware is up to date. We want to make sure that we protect transmission in the case that it's wireless or Bluetooth, so that way it's not intercepted and being used to access our network or our systems. And we want to make sure that we protect these peripheral devices to prevent data leak. So in some case, we might have to encrypt the storage device. We might have to remotely control some of these systems, like the embedded systems that would have its OS or interface to be able to manage, so that way it doesn't cause data leak or risk, impose risk in our network or our infrastructure. So for the next question, question 9, it asks about the risk for peripheral. You can list the ones that are identified on the notes, or you can simply include, right, wireless transmission issues, display. We want to make sure that we protect the screen so it doesn't display the data, private data, etc. So external storage devices, that can include data leaks. So you can identify the peripheral devices and correlate the risk accordingly. And for number 9, you can also find the answer on page 2 of your notes. And with hardware, we have some conditions that would relate to the hardware. EMI is electromagnetic interference. It's caused by signal being crossed on a channel, or it would bleed into another channel where it would cause some kind of interference. And the common one that you would see is when people wear their cell phone or use their cell phone near a microphone or a large speaker, and you would hear a high-pitched noise. That would be a form of EMI. EMP is electromagnetic pulse. This is a set of short burst electromagnetic pulse that is caused by electrostatic discharge, which can cause damage to storage and devices that would have storage. Lightning, or in the case where if you use this near military weapons, that can also have EMP effect. Such as if we have devices on military base where some of the weapons would cause EMP. So you want to think about how you physically protect the systems and logically protect the systems. Going into disk, for hard drive or solid state drive or external storage, USB, any kind of storage, we can think about how we can protect the data that exists on the storage. We can use full disk encryption, right? Most operating systems offer encryption tools, or we can use a third-party tool such as Veracrypt. Then we can also use self-encrypting drives. These drives have encryption tools built in, so when they get, right before they get disconnected, it would automatically encrypt the files and the data that would be stored on that drive. So for the next part of our assignment, question 10, it asks about the risks of EMI and EMP, and these, as we discussed with the electromagnetic static impact, it can cause hardware interruption, it can cause signal interference, which would disrupt the transmission of the signal, and it can cause storage damage. For question 11, it asks you, how should you secure storage disks? You can use encryption. You can also implement TMP, which I'm going to talk about next, to protect the storage. So in continuation with the hard drive or the storage, what we can do is we can set up BIOS or basic input-output systems to include software that provide basic instructions on how to use the actual storage, like USB, external hard drive, micro SD, etc. We can also use UEFI, a Unified Extensible Firmware Interface, and UEFI replace basic input-output system on, so you would see UEFI on the newer computers and system, now more of the modern system. We can use TPM, which is the Trusted Platform Module. This is a chip on the motherboard or the board that stores cryptographic key for encryption, and it is a physical chip, so we can configure it to secure and block access to the drive in the case that it falls into the wrong hand, it was lost or stolen. So in the TPM, it also allow you to have attestation, which we can change the boot files to report the information that's stored on TPM, so that way we can track. So there are a lot of different measures that we can implement, particularly when we're looking at storage disk or storage devices. With the hardware security module, in the hardware security module, security devices, our emphasis to secure the devices is to manage, to generate, and to store keys that would allow us to protect the data on these systems. Now, this is why when we were going through the storage, we need to think about encryption's hardware chip to be protected for the storage. This concludes my part 1 of the video. Please look for part 2 of the lecture so that way you can